So today we will start our discussion with our second project. I will share my screen. So I hope my screen is visible. So this is our second project's block diagram. The requirement is to have um, numeric controlled door lock. I mean password based door lock. We will have a password. Based on that password only we can open and close the door. Not closing, opening the door. Okay, closing we can do from inside, right? Or we can manage the closing automatically. Once the door closes, it will go into the lock state automatically. So for that we are using our microcontroller as the processor, and we have one solenoid door lock, and we have uh, audio visual indicator. So the purpose of this project is to have a deeper understanding of the software operating system planning, as well as the usage of control structures like for loop, while loop, and conditional statements. So we are going to use all these intensively in this project, because to achieve all these things like comparing, reading the numerical value from keyboard, and comparing that value with the uh, already stored password, and turning on that audiovisual indicator, also controlling the solenoid valve. These all require all these control structures. Also we need to plan some array also. So we are going to learn all these C concepts practically, like array, um, for loop, while loop, conditional statements called if else, everything. So this is the block diagram, a simple block diagram. One numerical 4 by 4 matrix keypad will be there. Also we have a solenoid door lock, which looks like this. Okay, it has two connections. It is 12 volt, 6 ampere, not 6 ampere, 600 milliampere solenoid one. So with the help of this, we can make our manual door automatic, or password based lock. So we need a circuit diagram for this. Let me save this first. So I have created one particular folder for this project, password based door lock. Block diagram. Now we need to draw the circuit diagram as well. Open Proteus software, go to schematic capture. I'm hitting P on the keyboard for shortcut. PIC16F877A. Now we need 4 by 4 matrix keypad. Okay, let's check whether we have a keypad available or else we need to draw one. Yeah, we have few keypads. This is also 4 by 4, 4 by 3. We will take this one. Okay. Actually, if you don't have keypad in Proteus, there are many ways to create it. You can just use switches. 4 by 4 matrix keypad looks like this. I will show in Google how 4 by 4 matrix keypad actually looks like. So yeah, if you purchase, you will get something like this. And schematic circuit diagram, if you see, yeah, it will be connected like this. Okay, so to microcontroller port, you can see P0, P1, P2, P3, P4, P5, P6, P7. So this is how we are going to connect our 4 by 4 matrix keypad to microcontroller. Okay, so this would be the connection. So we need to connect it like that. So this is not 4 by 4. Need to select 4 by 4 matrix keypad. This is 4 by 3. We will take this. This is 4 by 4. So all the columns. So we are going to connect our keypad to port B, because port B has a special feature called internal pull up. Okay, so we have pull up resistor. We have learned pull up resistor and its usage in our LED blinking switch interfacing class. Pull up resistor is used to provide a stable state on the input pin. Okay, so this is the need of pull up resistor. So we have pull up resistor available in port B. Other port don't have pull up resistor built in. But if you learn about the latest microcontroller like ARM series microcontroller, majority of the port have pull up resistor. You can use some register to configure it. Here also we need to configure pull up resistor. If you want pull up resistor, you need to write some value to a particular register. So we will learn about that while coding. So I am connecting all the column to uh, lower nibble of the port B, and upper nibble I am going to connect the row values of keypad, the row lines of keypad. So this is how the connection you have to maintain. And we have a solenoid valve, right? For solenoid valve, let's use a motor. So as we discussed in our previous session, we can't drive this solenoid valve directly with the help of microcontroller, okay? Because this solenoid valve uses 12 volt and it needs a 600 milliampere current. Our microcontroller won't be able to provide um, that much voltage and current because our microcontroller can generate only 5 volt, okay? So what we need is a driver. Maybe we can use MOSFET or transistor. I will take one transistor, PIP122, Yeah, you can see the collector current they mentioned 5 volt, and the operating voltage it can support is 100 volt. I am going to take this transistor. So here I am representing solenoid valve with a motor. Okay, motor, a simple DC motor. So we will connect that motor here. So this motor represents our solenoid valve. Okay, so this motor represents our solenoid valve, and the voltage we need to apply to that solenoid valve, they told already, it is 12 volt. So we apply 12 volt here. Then we need to ground this emitter pin. So we will have ground here in the terminals. Also there are other methods to ground, but right now we will use this. Now we need to connect, we need to choose a particular pin of our microcontroller um, to drive this transistor. We can directly drive this transistor. We need to provide a resistor in between um, the microcontroller pin and the transistor base, because we need to limit the base current. Let's keep 1K. If we don't limit the base current, there is a chance to get the transistor burned. Okay, so this is the second requirement. Now we have third requirement called LED and audio indicator. Let's draw it here. So we need a buzzer. So this buzzer can sound output via sound card. If you write the software to make it sound, you can listen the audio through your system speaker. Okay, so it has a property, it is operating at 12 volt. We can modify it to 5 volt. Also load resistance is there. We can increase that load resistance by 10. Let's see how it is going to work. So I am going to connect it in a way that you can use any pin. Okay, even port A, port E can use, but that need a different configuration. We need to configure trace registers to make it digital, because sometimes by default it will be in analog. So that's why, to reduce the complication, I am using the digital ports. Okay, this is the reason. We can also use these pins for port A and port E. Also you can use port C as well. So here I am writing, here I am keeping this 5 volt. And we need two LEDs, red to indicate the lock is properly locked, and one more LED green to indicate unlock. Connecting it to RD3. Then RD2. Also we need to place resistor we have already in our list. So value of that resistor should be minimal, like 220 or 330 or maximum 470. So we have almost everything ready for the hardware. Now we will go to the software part. I hope you remember the procedure. We have MPLAB XID. I'm waiting it to open. So every time professionals want to write software from the scratch, they do copy paste from the previous project, few things, but here we will start it from scratch. Okay, file, new project. What we have to choose is microchip embedded and application. Next, then you have to choose which is your microcontroller. 77A tool, you can select simulator, like maybe we will use MPLAB IDE simulator if some debugging need is there, software level debugging. Compiler, you can choose XC8. Then next, they are asking for a project location. I have a project location, that is password based door lock. Inside that I will create new folder called software. Inside that we need to give the project name. Password based door lock. There is nothing else remaining to set. Okay, finish. So here you can see left side our previous project is there. Also our new project is there. For the time being I am removing the older project which may confuse us. So I closed it. Now we have only password based door lock project. Okay, so the source file, we need to add source file. That's our code. So right click over here, source file, main.c. Here they are asking file name of the source file. I will keep main, and the folder is going to be the same. Now hit finish. You can see one file got generator. I usually delete this portion. If you want, you can maintain, you can add the information related to your project over here. If you want, you can do that. Now the regular process starts. Like we need to define our hardware by examining the circuit diagram. So here lock is kept at RD7. So I am writing like hash define lock RD7. should be capital. Now we have LED green and red. Red we will indicate lock, green will indicate unlock. So LED red I am going to call um, LED score lock, which is set RD2. LED unlock is there, which is at RD3. Now what is remaining? Buzzer is there. It's at RD4. Hash define RD4. Okay, RD4. Now we need to define the statuses of this pin. For locking, we can write lock or unlock, hash define lock. Lock is already defined, and so we will use some other word. Hash define enable we can use, or else yeah, enable. Enable means 1. Now hash define disable. 0. Now statuses for the LED and buzzer. You know, to turn it on you need to make it 0, and pushing it back to off you need to make it 1, because the biasing is like that. Hash define on 0. Hash define of 1. So we did the basic hardware level picture. You might be thinking why we are not writing anything about port B. Actually, port B is a group of switches. We are scanning the port entirely by using a function called read keyboard. Okay, so whenever we call a function called read keyboard, that function will return the value, whether the keyboard key, whether the key 1 is pressed or 2 is pressed, or any other numerical or functional keys are pressed. Okay, so that is a different scanning method we are going to employ in our software code. So we will learn it in after few minutes maybe. So this is the basic hardware information we provided. Now we can usually, as usual, we can start initializing the port. So we need to write tris register value first. Tris d equal to tris d equal to 0 x, which are the value port, right? RD7 is output. Almost all the pins are output here. So we are blindly writing 00 over there to make all the pins inside the tris D port as output, because you can see there is no input connected on RD0. So we don't have to um think too much about the tris D value here. Also regarding port D, that we might have to think port D equal to what is the value. If you keep everything 0, all the LED buzzer will turn on at the time of initialization. When the microcontroller is powered on, you can hear the sound of buzzer and you can see both the LEDs turned on. So in order to stop that, you need to write 1 over here. Okay, so 1 over here. If you write 1 over here, solenoid valve will be working, right? So you don't have to write 1 over here. You have to write 1 at these places only. Let's see what are the values coming. You need to have 0 here. So 0, 0, 0, 1. So 0, 0, 0, 1 means 1 only. Now the remaining part, we need to write 1 over here, 1 over here, don't care, 0. So double 1, 0, 0. So what is the value? 0, 0, 0, 1 means see, I am writing it 0x 1. Double 1 double 0 is C. So 1C. See, you can see here. We need to keep 1 1 here. So 1 1 0 0. Go to calculator if you have doubt. Calculator. Go to programmer. Put it binary. Write double 1 double 0. You can see hexadecimal value 0. So that's what I wrote here. Now we need to plan the software. Whenever the device powers on, you need to hear a beep sound. For that we can call a function called beep. We need to write it, the function we are going to call a function called beep. Okay, we will write what is inside the beep later. Maybe in this session we will focus about the working of keyboard, okay, and how we are going to implement that. So okay, for that we need to have initially we will listen a beep function, then the system will scan for then the system will show whether the door is locked or unlocked by checking its status. For that we need a variable called door status. Unsigned care door status. We are initializing the variable to 0. So door status is a variable which stores the status of the door while when the system is powered on. We are thinking that door is closed. Closed means 0. Okay. So don't think that this is a top level door lock system. So we our intention is to learn the operating system planning as well as the concepts of C basics, C principle. So yeah, So if you think a good door lock system, it need a different way, different approach. Like we need to store the door status in a permanent memory like EEPROM, because every time when the system goes to power off and power on, it need to store the status, right? Whether the door is locked or unlocked. So there might be some different approach. There should be some different approach needed. So the door status variable will store the status. Based on the status, it will tell initially. So after the beep, we are checking if door status equal to, we have to write few constant as well. Let's define open one hash define close 0. So if door status equal to open, we are telling the lock equal to disabled. Open means disabled. The solenoid valve won't be working. It is locked. Sorry. Yeah. So it should be close. Okay. Close means lock is disabled. I mean, the door is closed. Else, you can copy the entire line and just modify disabled by enabled. Okay. Now the system will work based on the status which is there at the time of initialization. So this is not the right way. We need to read it from EEPROM, I already told. So we will learn it in future how to use EEPROM for storing the value permanently. Okay. Now we need to examine, I mean, read the keyboard. Okay. In order to read the values, if someone is putting some code over there, we need to read that code. So for that we write a function. We will write a function called read keyboard. Read keyboard. So if we call read keyboard, we will get a few numerical values from the keyboard, and we will verify that value with our password. Okay. So password we will keep 1234 for the time being. Let's say unsigned unsigned care password. Size we need to mention, or else we can, yeah. And it is 1 comma 2 comma 3 comma 4. So this is our password. And yeah, I need to explain something regarding the array. So this is an array in C. So the type of the array is char. I mean the value which each position. Here you can see the size of array. So this is the syntax. You need to name an array. You can call any name. Here the name of the array is password. You can keep your name if you want, but you have to use it. So everywhere the meaningful word we have to use. So this is the data type, user defined data type array. So the type is character. I mean each position can hold a value of 0 to 255. It is unsigned. If it is not unsigned, it can contain minus 125 to plus 125. Okay. So for position, it can store four values. If you put 10 over here, it can store 10 values. One thing, one more thing I wanted to add related to array is you can read it over Google to learn more about array. But these are the basic things you need to understand. Array is a group of similar elements. Okay, so entire things inside the array will be similar because you're doing it initially telling the type of the array as char over here. If you put int over there, you can store four different integer values in all these four positions. So you need to mention the type of array elements, data type, then you need to name the array and give a name for the array, then you need to mention the size. If you have elements during the time of initialization, you have to mention those values, otherwise you can keep 0, or else you can write like this also. I will show you how can write initialization, how can define an array without initializing it. You can also write like this also. You can also write like this. No need of initialization. The value would be 0 or some garbage value. So here we need a password. So the password is 1234. So we are keeping it like that. So when you will become an expert in coding, you can take values from keyboard and you can store it in this array. Also, you need to make this password array inside the EEPROM, or else you have to maintain this password memory in a different way so that user can update their password whenever they want. This is a constant password. After writing the code into the microcontroller, it will go and stay inside the flash memory. It will be a part of the program code. This is the um, this is how global variable works. Global variable will be part of the um, program memory. So yeah, in our we have a syllabus, right? So in the syllabus, we are telling that at this stage we will be discussing bare metal operating system. So there is one thing missing. This is the one in previous lecture. After previous lecture, we have to discuss this one, memory allocation. So maybe I will plan a session or I will record a session related to memory allocation, how the memory is allocated inside the C program. Then after that session, you will be having a good understanding how the variables we are declaring, how the constants we are declaring are going to reside inside the memory. So that is a must need knowledge in embedded system. After uploading the video, I will inform you. Okay. So yeah. So let's begin writing the function read keyboard. Void read keyboard void. Void means, you know, right, it is going to return nothing, it is going to receive nothing. So this is a function called read keyboard. The duty is to read the port B register and come up with a value. Yeah, come up with a value. So read keyboard is not going to receive any value. Keyboard is not going to return any value. Now it will uh, it will store key value. Okay, so we need a variable called key value. Before that, I will explain the working of keypad. Then only we can write the code. For that, I need to open the schematic. You can see here we have 1, 2, 3, 4 columns and 1, 2, 3, 4 rows. Okay, so the concept is we need to identify which is 1 and which is 2 and which is 3, like that. So we are going to yeah, we have already here 1, 2, 3, 4, 5, 6, 7, 8, 9. So this switch represents 1. Okay, so microcontroller is employing a different algorithm here in order to read the keyboard, actually scanning the keyboard or read the keyboard. First thing is, you know the working of switch, right? Switch is simply a metal contact. It will come into contact when we are pressing it. It will detach once we release it. Okay, so let's see. Some current flow should be there in order to make a change, right? So when see this particular, I will draw the switch separately over here. This is the switch represents 1. Okay, this is the switch represents 1. We will learn how the value 1 is going to get inside the microcontroller. So this is R1. Okay, this is C1. So numerical value 1 sits in C1 column and represents R1 row. Okay, so what microcontroller will do is, initially microcontroller will keep R1 high. Okay, microcontroller will write 5 volt over here. They will write 5 volt over here and they will write 0 volt over here. So 1 is here and 0 is here. When you press the switch, 0 will come in contact with 1 or 1 will come in contact with 0. 1, you know, it is 5 volt. So when it comes in contact, the value of this one will become 0. This is the basic electronics knowledge you needed. The current will flow through this direction and you will get a 0 over here. So what microcontroller will do, right? So once microcontroller writes a 1 over here and 0 over here, microcontroller will check whether someone is making my pin to 0. Microcontroller already wrote 1 over here and it is examining who is making it 0. So if it makes 0, microcontroller will understand, right? So this is how they are doing it. So let's write something like, so initially all the row would be kept in 1. Okay, all the rows would be 1. Initially all the row we will keep 1, all the column we will keep 0. So this is R1, this is R4. Okay, all the rows are 1, all the columns are 0. So this is column 4, this is column 1. So the switch 1 is R1, this one and this one. So once it comes in contact, the value will change, right? This value will become 1 1 1 0, and this will be 0 0 0 only. Okay. What are the other chance to become this particular pin 0? See, if you press value 2, it will also make R1 0, right? Because C2 is 0, right? C2 is 0. And you are pressing the second button. This will also bring 0. Also C3, also the third button will also bring 0. Also the fourth button will also, not fourth button, button A will also bring 0. So controller will be confused whether it is 1, 2, 3 or 4. Now, in order to identify exactly whether it is 1 or 2 or 3 or 4, controller is employing a different method or algorithm to identify it properly, is that it will switch immediately. I mean, once it sees a change in the port, once it sees a change in the port value, the port value which microcontroller wrote was 1111, right? Now it is seeing a value change. The new value, microcontroller will save the new value, and it will call the new value as raw value, RV, raw value. So raw value is now 1110. Okay, now you got a new raw value. Immediately microcontroller will switch the voltage level by its own, making all the rows 0 and all the columns 1. We can do it, right, by managing the port pins. Okay. Now all the columns are 1, all the rows are 0. This is the value RV. This is the value RV. Okay. And we have new row value and new column value by microcontroller. Now see what happens. See, we pressed 1 only, right? If we press 1 over here, the new value is 1 over here and 0 over here. The current will flow this direction and it will make this pin 0. Okay. So again this pin, again C1 will be 0. C1 will become 0. Now here C1 becomes 0. Remaining pins will be high only, right? C1, only C1 is going to make the change. See, there won't be any change on these lines. Only C1 is going to do that. Okay. So C1 will become 0. All the pins, any switch related to this one, any switch connected to C1 can pull the voltage to 0. Okay. So we will get a new value 0, 1, 1, 1. Remaining will be 0 only, right? Okay. So now you got column value CV. Column value. Column value is this one. 1, 1, 1, 0. Now to make it clear, let's see if we were pressing 2, the button 2, the value will be like this, right? Button 2 represents this one. It is raw 1 only. So the raw value for button 2 will be 1 1 0, and column value at that time will be 0 0 0. After switching, uh, column value will be all 0, and this is the second button, so it belongs to C2. So 0 0, oh, sorry, we are making it 1, right? So 1 1 1 0 1, because we pressed button 2. Okay, so button 2 will make column 2 0, button 3 will make column 3 0, button 4 will make column 4 0. If you have time, examine all the button, take the combination. So here the new combination is the old combination. This one is for 1, okay, this one is for 1. For 2 the combination is triple 1 0 double 1 0 1. So what programmer has to do is, so he need to check whether the row value is triple 1 0 and column value is triple 1 0. He will tell the key value is 1. If the row value is triple 1 0 and column value is double 1 0 1, he will tell it is 2. Microcontroller will treat as button 2 is pressed. This is the mechanism. If you have doubt, listen to the video one more time uh, and come back. So likewise, you will have values for all the buttons, right? I will tell you the value of 3. Okay, so 3, you are going to press this button. So if you press this button, the column value, row value would going to be the same, because you are going to press R1, right? So the new R value would be triple 1 0 only, but C3 would be changing. C3 will become 0. So C3 will become 1, sorry, column value will become 1 0 1 1. Okay, so 1 0 1 1. So triple 1 0 and 1 0 1 1 belongs to 3. Triple 1 0 and triple 1 0 belongs to 1. Triple 1 0 and double 1 0 belongs to 2. Triple 1 0 and 0 triple 1 belongs to A. Likewise, you will get a combination of 8 value, a combination of 8 value, row value and column value. Likewise, you will get total 8 column and row values. Based on this, you need to implement. Okay, so inside that you need to perform all these, like initialize the trisb. So you need to make trisb equal to the condition. You need to read the pin. Okay, you are going to read the row value initially. So all the row pins should be input and column value should be output, because we are going to write value at the column pin. Okay, so column value would be column pins should be output and row values should be input. Go back to this one. This is the row pins, this is the column pins. So row pins means RB0, RB1, RB2, RB3. So the lower pins are row pins, rows are input, so it should be 1. So we are writing a value over here, trisb equal to 0x 0f to make it input. Also we need to write initially we need to write 1 over all the column, right? All the row, row means I will write over here row belongs to, row means RB0, RB1, RB2, RB3, RB0, RB1, RB2, RB3. column means RB4, RB5, RB6, RB7, RB4, RB5, RB6, RB7. So these are the column pins. So initially we are making row pins input, column pins output. Okay. Now we need to write row value port B. We need to make row value high. So port B equal to 0x 0F only, which will make all the raw pins 5 volt. Now it is our turn to read the value. Now we are going to get a raw value, right? Because we made all the raw pins high. If someone comes and press the switch in the row, we are going to get some value. We need to know that. Okay. For now, what we have to do is use the while condition. While someone comes and reads it. While someone comes and read port B, while port B equal to the written value. If it maintains this value, stay there. Yes. Yeah. How? I will tell you. See, column represents, this is column, right? 1, 2, 3, 4. This is column. Yeah, port B. So RB7 to RB4, it is column. Okay, so let's see. RB4 to RB7, it is column. We need to make it 0. Okay. Remaining pin is RB3, RB2, RB1, RB0, which represents row. We need to make it high. Yeah. 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 So okay. So yeah, what I was telling, we wrote a value already in the on the port, which is 0x0f. To get some changes, someone has to come and press the key. Someone has to come and press the key. Then only the port value will change. So we are telling the controller to wait until there is a change. This is what this statement tells. While port B equal to 0f, we are telling the controller to continue. We discussed all these things like while, continue, break statements in our previous lecture. So while port B equal to 0x0f, continue. If there is any change, controller is going to understand that there is a raw value. There is a new raw value at the port. So we need to save the raw value. So unsigned char raw value. Raw value. So what we are going to do is we are going to save the raw value equal to port B. So we got a new raw value. Now it is microcontroller's turn to make the port pins value opposite. Now we have to write opposite value F0. We are going to make all the columns high and all the columns, all the rows 0. F0. So we made a switch uh, in the row and column values, and we will do the same. We will wait while port B equal to F0, continue. And if there is any change, if the user is still pressed that key, it will all these things will happen in nanosecond, microsecond time duration. Okay, the time required to press and release a switch is 1 second. We can do it quickly. Even the software will execute even more quicker than what you think. Okay, so this will happen in microsecond time. So while port B equal to 0x F0, we are telling the controller to continue there. If there is any change, controller will understand that there is a new column value. Okay. So controller has to save it. For saving it, it need a variable memory location. So we are creating it, column value. So yeah, column value equal to port B. This is what column value equal to port B. Now we have both row value and column value. Okay. So an actual programmer, before writing program, he will have all the sets of values. Okay. So he will use his brain to calculate all the possible outcomes coming from this combination, row column combination. Okay. So what he is going to do is he is going to examine if row value equal to if this key is pressing, this is going to become 0, right? So 7. Okay, so in case of 7, we are going to get RB0 equal to 0. So what would be the value? 0 0 0 0 1 1 1 0. This is 1 1 1 0, which means triple one zero 7. Triple one zero means 7. If you have doubt, go to calculator. Triple one zero. Oh, sorry, it's E. I'm sorry, it's E. Uh, so row value equal to 0x 0e. Row value equal to 0x 0e. And this is how we use conditional statement and some combination of logical operator and column value. We got both the values, right? Column value equal to what would be the column value? 7 represents this column, right? So this column stays here at RB4. After column change, this is going to be 0 if if the button is pressed. So 1 1 1 0, remaining all are 0. Okay, so triple one zero means E. So here also we are going to write 0x E0. Okay, so if this is the case, key value equal to, so we need to have a new value called key value. Key value. So key value equal to 7. So this is ASCII 7. Okay, so that's why I put in single quote. So key value equal to 7. You can make your own keyboard by putting a sticker over here. You can make it 1, or you can do whatever you want. You can write B, C, Z over here. What you want to return, you have to write it over here. I want to return 7 because this keyboard represents this position 1. Previously, this keyboard represents this position 1. So the keyboard pattern is different. Based on that, your programming mind has to work. So I am getting a value 7 here. Likewise, you have to write all, all the value for all the combination. So we will write the remaining uh, values in next session, maybe next Saturday. We can wind up here. The logic is simple. Uh, Keeping the raw value high at the first time, then checking the switch press, then after switch press making the raw value um, opposite to that previous column value, then reading the column value, then comparing the column value and raw value, um, if with a constant, like if we have a combination of 0 E and E0, we are returning key value 7. For understanding, we will write one more. Else if, so else if raw value, suppose we pressed 8, this would be the same, right? So everything sits in the same row. So if it is 8, it should be E0, and 8 represents this one. 8 represents this one. So RB5. So 1101. What is 1101? Go to calculator. 1101. It is D. So we are writing D0. D0. D0 is 8. Okay. Likewise, you can examine the hardware, understand the key value, then you can have a key value over here. So read keyboard will come up with a key value if it called and user pressed a key value. We need to manage the software. So in front of you I just wrote, so for a proper door lock we need to have a proper software planning. Once the read keyboard functions function get complete with proper output, we can manage the read keyboard function in a different way. So we will learn all those things in the upcoming lecture, okay, series. So thank you for the day.